very easily implement any runtime for any programming language. Probably is interesting mostly for compiled languages that are not only Go, they are only Rust, for example. There is Haskell, that is something that interests a lot. I like it a lot, Haskell. There's a nice language like NIM, and there's C++. So the idea is to generalize the approach that we have used so far for Golang and using the Go proxy, implementing the action loop. So a runtime should actually make the action loop transparent to the user. The user should simply send an action, and that's it. Then that internally, the runtime is implemented with the action loop. That is that snippet of code written in multiple programming languages that read a line of code, pass in JSON, send to the action, and repeat forever. So far, I actually implemented 4 runtimes that uses the action loop. One is the raw one that needs to that works with Bash mostly. Then the second one is the Golang one that has a number or is pretty extended as we tested. There's examples, there are documentation wrote, so it's pretty extensive. So that I would say the Golang runtime is ready for prime time. Let's say so. But also I implemented the runtime for Swift, because there's a lot of common. Actually, a lot of things that I have done in the Golang are taken from what they were in the Swift runtime. So in a sort, they were influenced each other. And now the Golang runtime is pretty close to the Swift runtime, and I implemented the compiler. I will tell you what is the compiler for Swift. And also I did an experiment that actually was pretty fast, implemented to do a Scala runtime that I think is pretty interesting, because I have heard many people would like to have a runtime for Scala specific, not just building the one. That is the one that I was showing. So to explain this slide, I created actually a separate repository. The is actual loop runtimes, where I try. That's a fork of the Golang repository, and here you can see how it works. Basically, each runtime is implemented by 2 files: the launcher, that is basically an implementation of the action loop, and the compiler, that is basically one piece of code that will take the action that we send and will join to the launcher, and that's it. Okay, there is also a Dockerfile to be built, but the steps that are needed to create a new runtime for a new language, any language, using the action loop is write a launcher, that is the small script that we have seen for Scala and Bash. Write a compiler, that is simply a Python script that will take the action that we upload and then join in some way that depends on the language with the launcher, bundle everything in a Docker image, and at least write the test. That's it. So I think so far I have done for Swift and Scala, not yet written the test, but I will complete as soon as I can. This is an example of the action loop running the Scala runtime. This is what you see is the action. That's a very simple. It's a very simple action written in Scala. And then using the runtime that is created, just writing a compiler and a Docker file, is up and running in IBM Cloud. So you see below the action create using the image action loop Scala that I put in my personal repository, and then I invoked it, it worked. Well, I had to use a bigger amount of memory because it didn't work with the standard amount of memory.
Hmm.
One thing to say, this Scala runtime is not really based on Scala. It's based on Ammonite. If someone knows it, is I would say awesome Scala shell that supports a number of magic imports. So when you play with use this one, it's not like working with Scala in the classical way with IntelliJ IDE and you compile things. No, it's much more like working with Python or Node.js, because it's you have a read developing loop, and I write things in the editor, then I in the command line, and then there's a way to import on the fly libraries, on the fly other scripts. So it's much more interactive as before. And then I use that's Ammonite I put in the runtime, and I send to the runtime the script that I normally write in my command line. And this is what at the moment the Scala runtime does. It's something similar to what people do, for example, with Zeppelin on big data. So this can be very interesting for people interested in an interactive way of working for artificial intelligence applications. So I think there are people already talking about that. So it can be useful. I was even thinking to extend this to interact with Spark, but this is another idea that I will try to develop later. So what's next? Well, first I want to complete the Swift runtime and the Scala runtime, of course. Second thing that we have discussed many times is to use action loop to be sort of Docker schedule version 2. So I need input here because there's many open points. But again, this has been said by Roderick and Carlos, so I need input on this area to make action loop the new version, the new Docker skeleton. And then I would like to implement some other programming languages. Another one I would implement is Haskell, but also can be useful to do support for Rust, for C++, for well, there's NIM, a very nice language compiled. I have this idea of Erlang, but I don't know if it's worth or not. Anyway, those are just ideas, but it's where I'm moving. And where I'm moving forward the work I've done so far. Okay. Question?
I have some live feedback, but I can give it. So first of all, this is awesome. It's not the first time I've seen it, but this is something that I've been working with Michelle back and forth. So there's been a lot of thought from Michelle and also me, but more Michelle on how to do this. So a few comments. One thing is for everyone to benefit is OpenFast has the same concept. They call it watchdog. So when I met Alex from the OpenFast team, I was going to tell him that we were going to call ours watch cats. I didn't want to call it. So yeah, I think action loop is okay. But it's the same concept. Is they're using a standard output, standard input, using pipes, not using HTTP stack. So you're going over IPC in general. That's why it's so fast. So that's one aspect. So this is not like an experiment. We have some validation from OpenFast. We have validation from Michelle that have done some benchmarking, and we're breaking this on Unix, on pipes, and IPC. So this is something that is robust, and we already doing it with the Docker skeleton. It's just that we are like putting out the standard outputs at the last line, and that was convoluted. And then we have the Python overhead, and using Go makes it more faster to have an HTTP proxy. Yeah. So this is very good.
The problem on the Docker skeleton is there is a huge overhead to forking a new process.
Yes.
When I started everything, I did some benchmarking. I got the very bad numbers, and then I did some benchmarking getting very good numbers if keeping the two processes. So the two processes talking each other.
Which other IPC?
Very fast. The only overhead is the passing of the JSON, but that's all.
Yeah, that's something that we need to maybe add tests of like large payloads in and large payloads out, right? Like 5 megs worth of JSON and encoded. But I think that could be on top of that integration performance test, on top of this. The other thing is, one aspect, just to put a pin for the future, is I think Tyson, Adobe, and also me, we're looking into supporting some type of multi-concurrency. So it'd be worth just for the future investigating to see if the action loop can, because since it's a standard input and you're waiting for the standard output on a certain file handler, if we can implement some type of concurrency, so we can have as more actions are coming in and we want to support X amount of concurrent actions, we can fork a new process. So it's and see if this is busy or not busy. So that's something, and that way we can have
but you could fork. Yeah. You could fork multiple actions in the same runtime if you
in the same runtime. Yeah, that's exactly. So you have multiple things running at the same time, and the action loop is just waiting for them and know which one is busy, which one is already done, so you can send it the next standard input. That way we can have
round robin. I would do a round robin, so I will feed in order.
Yeah, the next one available, right?
Right.
Yep.
Okay.
Yep. So good feedback. Yeah. Sorry. This was my feedback in terms of that, and also context. We have to think about for the future. I think with the multi-concurrency, the activation ID and deadline, which is like time to live, will become the context object. So that way, I think we can have more similarity with other not open, but other serverless platforms and solutions, that you can write your code with an event and a context object. So it takes two parameters, and you can take that function as it is and move it to some other platforms. And because a lot of people are doing that context object, and Tyson brought it up in one of the issues, and I think that will be the answer, to store the unique information for that single invocation in a multi-concurrency environment. But yeah, this is good, and then this will help with Swift 4.2. I'm excited about Golang. That's a language I'm learning. This is good. And the only thing is just bike shed over what name do we call it. Like today we have in the CLI --native. Do we call it --native v2, or do we call it --native loop, or we call it --loop? So it's a sugar for which image to use, and that's the easy part, right? Naming things. Okay. Yeah. Anyone has feedback for this?
Yeah. I have a question. So how will this affect the existing runtimes? Are we going to change them accordingly? I'm not sure how this action loop relationship with existing runtime like Node.js, PHP, and anything else.
No, it doesn't apply. Node.js, I think Node.js stays as Node.js, and PHP stays as PHP. It will be a change for Swift, but this will be a new runtime. We don't want to change the runtime because people already wrote their actions and deployed them in production, and they have them running. So it will be a new kind. So --Swift 4.2 will be much faster. You can have stuff in memory, that's I'm excited, right? You can store all this stuff in memory. You don't have to shut it down like today in Swift. That's why it's so slow. Not so slow, but it's compared to the other runtimes, it's slow.
I would use it mostly for compiled languages. So only Rust or C++.
Okay.
Yeah.
But
will be new images. Yeah.
It will be worth to consider for Java, because or at least for Scala, because Scala. Probably I'm thinking to change something and use actually compile on the fly inside the runtime instead of doing like now I'm using Monite. I have to check better, because actually my goal is to connect it to Spark, because I am not interested in having Scala for himself, because it's pointless. The important thing is that you can have inside the runtime a support specific for Spark. That is the really interesting thing.
Spark. Oh, interesting.
Yeah, but this is my real goal. I don't care to have Scala in the runtime, because I can do that. I want to have all I need to run connected to Spark.
Yep.
That's the thing, because it can be an alternative to using Zeppelin. That is, in my opinion, is terrible, because we have a lot of slots very small. Then if you can have a collection of scripts that you can upload in another time, you have a better alternative to things like Zeppelin that is a big, the real nightmare when I do big data application, that unfortunately is part of my job.
Yeah. And I've seen Haskell and other platforms and Rust.
Haskell,
So Rust, there's a
Haskell is
person.
the functional programming, the pure functional programming that is going to be compiled.
Yeah.
So that could be done more or less in the same way as Swift. Because you have a package manager, you upload action, then put an action loop, compile, and get a binary. So that's and also Rust works the same way. You have don't remember the name, cargo. You have the cargo builder, you put a piece of code, you compile everything. So it will work. And then you can leverage the pre-compiling method that we have in the Golang. So it's all of this makes sense for compile the languages.
Yeah, and
we can keep as they are because they make no sense to change way.
Yeah, in Twitter and in Slack, there's a person already looking in Rust, and he's very excited about getting Rust to work in OpenWhisk the current way. So having the action loop, and maybe I'll contact him to see if he can just share what he's been doing, so we can combine that. And I think James actually did a blog post eons at the beginning. He got Rust running.
One day you can implement that one day in one day. The biggest part is to learn enough for the language to write a symbol, read the parse JSON and write, and then compile. Right. The rest is simple because it's a very simple Python script, and then very simple Python script and a snippet of code. The same, everything else is the same. So it's very easy.
Yeah, so we should learn those two things. Okay, so we for time.
Just add one more comment there.
Go ahead.
Michael, this looked cool. One aspect which I liked, and with something we can probably think about taking it back into, let's say, other runtime, is like in the Scala one, there's this IV used to import dependencies directly from Maven repo. So you don't have to add all those bulky jars as part of the action code, and which takes time to download, and we have limits there. But if we can refer to those and the runtime can dynamically download it and prepare the class loader with those jars, then that would reduce quite a bit of development time, as the developer only needs to package his code and the third-party dependencies would be download that. So I think that is something we can see if, let's say, probably look into making it part of the init protocol, where the init protocol can say, this is the action and these are some of the other dependencies that you might need to prefetch, so that instead of pushing it from your artifact store, the runtime can directly pull in. So that I think we can later looks a very useful construct to take it in other runtimes.
The runtime as a precompiler has the ability to run the init step in a offline way. So if I build a compiler for Scala that will create a big jar for everything, I can build a big Uber jar on the fly, and that is everything resolved that you don't have to download. So I would leverage this feature that you can precompile the action and have everything there, so you don't have startup time to download things from the. For Golang, we already did that. There is already a pre-compile step where you download, pre-download and pre-build everything as a single binary. So we can do the same also for Scala.
Yeah, the idea, Michael, I was pushing for is not to have everything pushed into the artifact store and have invoker download it and push it back to the runtime, but rather the runtime can pull in the runtime dependencies directly. So
yeah, I agree.
But the compilation part is fine. We can compile only the our code, but the rest of the dependencies can be pulled directly from the very fast local caches of the Maven repo. That is something we can look into.
We can discuss on the mailing list. The best way.
Yeah. You don't want your co-stars to take 5 minutes, right, Chetan? Downloading stuff from the web. it depends.
No, but but if you have like on that local host, you have an M2 proxy, So the open source jars, at least the third party, which are not private to the customer.
The operator can cache and
Cache
have
and
everything closer in-house
closer to
inside the
the
cluster
in-house.
Kubernetes. Yeah, I know. I was messing with it. Okay. I think we are up for. Did somebody else had any comments or any excited or want to help or learn more?
I just want to mention Michelle again and Carlos. I know you both worked, so this is looking really well. You got me thinking whether there are things that could be extracted, such as the one mentioned by Chetan, that Node.js and Python also could benefit from, and the initialization could be one of them. I also noticed that, for instance, if you go in Google Cloud Functions, they also compile. I think Google does create a Docker image, I believe, but don't quote me on that. So when you update the function, something happens behind the scenes, and there's a compilation step before the function can be invoked. So maybe we can leverage this in OpenWhisk somehow. But these things and other things that you think may come out from the action loop concepts that could be used in Node.js.
Actually, I would try to do a benchmark because I have not yet tried. But I have a suspect that can be even faster than the current one. But I have no time to try, but I will soon try to benchmark and see if an actual loop based can be faster than the current one. Could be, but I'm not sure. I will discover soon.
Yeah. So in regards to your comment, it's a bit orthogonal to this piece of action loop, but I agree with you, and those are the things I'm also already looking into on how to improve the user experience in terms of dependency management, because that's kind of like the people go over that. So for example, in an action, you can put a metadata, or we can start with an annotation that you put your package.json. You don't have to upload those things. There's also discussions on, can I have my dependencies put in S3 separate from my code, and then we put them together at runtime, and also on creation. Been working with Knative, and Knative is all based on immutable containers. So when you create an action, like the work that Ben have done with KWSK, the concept of when you create an action or upload an action, something gets triggered. We can use serverless for serverless. Something gets triggered for running this compiler code that Michelle has to compile the code on your behalf and store it in S3, or store it as an immutable container somewhere in the cluster. And when it runs, you're actually running the container. The invoker is not doing like downloads of 50 megs of files or trying to put those things together. So we lower the code start to just a Docker run, and but to the end user is transparent. You just gave me some piece of code and a package.json. For example, this is just a Python, the Node.js. I guess Python, you can give me like a requirements.txt and a Python script, and then I deal with the rest. That's kind of like your vision of go forward.
Yes, and you know what? Besides this, I also noticed something interesting. Like for AI actions, you have the code, right? But sometimes you may also have a model that you want to download. So there's this dependency that you might want to get before running.
That is not code. Other artifact that is not code. Yeah. The models, which are sometimes are big, right, for the AI actions.
Yes. Yeah, we're talking between, I don't know, maybe 50 to 200.
And we get into the territory of what we call it, the memory, the serverless storage, the serverless memory cache concept, right? Having that volume on all pods, if we're talking about Kubernetes, available with that historic data. I think we're almost done. Final thoughts, or we move to any comments? James, you did Rust, so I don't know if this will help based on the work you did with Rust, but I think it will be very useful for any compile language. So I guess the COBOL guy will be very happy. The guy that did COBOL.
Can you read the standard input and write the standard output past JSON in COBOL?
No, I didn't see it. But somebody did a COBOL thing, so
Okay.
I'm happy to support all runtimes, all languages. So, so who wants to run the next meeting? Look, my calendar is it will be on the. Oh, I think I forgot to mention some of the. Well, I can just mention it. The Go language. Michelle fixed some of the final things on vendors, and the .NET. The repo is created. I work with Infra, and I need to work on Travis to push the images and CI/CD pipeline. I think that's the updates. Any other updates on your side, Dragos?
No.
Okay, yeah, that's
I'm prepared, so I'd say no.
that's fine. And Cube, the Cube repo is getting more love. Dave is in vacation. He didn't make it today. His wedding anniversary, so he took a vacation day today. But we're getting more issues, so that's good. More people are trying the Cube flow to deploy OpenWhisk. It's very easy. Docker desktop offers you Kubernetes. You do a Helm init, Helm deploy, and it's very easy to deploy. So for those people that are learning or using Kubernetes, it's becoming easier to run on your laptop. So he's been looking into those and answering questions and also answering issues. There's as more people use it, they find more problems, and that's good. We keep updating them, patching them for Cube. So I think it will be November 7. Any volunteers to just gather the agenda and just run the meeting and watch out the time?
Yeah, I can do that.
Okay. Going once? Okay. So Vincent will be handling November 7. And Matt, as always, doing the awesome notes. I don't know, with his magical AI part, bots or something. Always impressed. Okay, so that's it for this week. Thank you for presenting, Michelle and Vincent, and for others for attending.
Okay, thank you.